So this video is going to be about double replacement reactions. And so double replacement reactions are a kind of reaction that happens between two salts. Okay? Oftentimes you'll find this kind of reaction in your cooking, in your stomach, right? All sorts of biology applications, in your plumbing, all sorts of different places where salts get to meet together. And so a salt is just a combination of a metal and a non-metal. And so two salts, you have metal 1A plus metal 2B, right? So what happens here is metal 1 will pair up with B, and metal 2 will pair up with A. Okay? And so what happens here is that there is a double replacement, right? You can kind of think about this reaction as two single replacements, right? Two single replacements, but it's useful to think about it in this way. So metal 1 pairs with B, so metal 1B, and metal 2 pairs with A. All right? So, for example, if we had sodium chloride dissolved in water, and we mix it with silver nitrate in water, okay, what will happen is, well, these are two salts, and so A and B can kind of switch places, right? You can also think about double replacements as A and B switching places, but in any case, the ions are recombining into different forms. And so we have sodium plus ions, chlorine minus ions, silver plus ions, and nitrate ions, right? That's what these salts are composed of. And so sodium is going to combine with nitrate, right? So plus one forms sodium nitrate. And silver and chlorine are going to combine together, silver and chloride. And you're going to get that, okay? Now, I'm going to be writing solid here because if in these kinds of reactions, we have to pay attention to the state that the salt is going to be in, right? In most cases, what we're going to be doing is mixing together solutions, that is, dissolved salts, together. And so to know if a reaction happened, we have to look for a change of state. Okay? In the reactants, both of them are dissolved in water. In the product, we see that something has precipitated out. And so silver chloride is going to be a precipitant. Now, how do I know that it's going to be solid? Well, I'm going to look at my chemical information sheet. The solubility rules will tell us about the solubility of certain salts. Okay? So for example, salts in the group 1 are salts containing group 1 elements that are these ions. All of them are soluble, right? And as we go down this list, right, we just want to read through the rule and try and figure out whether that compound applies. So for example, AgCl, right, that's our salt. Well, AgCl doesn't contain ammonium. It doesn't contain nitrate. It does contain chloride, Cl-. So let's read this rule. Salts containing chloride, bromide, or iodide are generally soluble. Important exceptions to this rule are halide salts of silver plus, lead 2 plus, and mercury 1, 2 plus. Right? Thus, AgCl, PbR2, and Hg2Cl2 are insoluble. So we have AgCl, right? So that means, according to our rule, AgCl is going to be a solid. Okay? Let's try another example. So let's say we mix together sodium bromide and potassium iodide together. So first step here is we want to break down each of these into their ions. So sodium plus, bromine minus. potassium plus, iodine minus. And so they'll recombine, right? Sodium pairs with iodine, bromine pairs with potassium, and so you're left with sodium iodide and potassium bromide. Now let's try and figure out the solubilities there. Sodium iodide, well, salts containing group 1 elements, so sodium, are soluble. So this is a salt that contains sodium plus, so it is soluble. Potassium bromide, same thing, group 1 salt, group 1 ion, so it is soluble. So looking at the change of states, we have dissolved things before, dissolved things after. So what we would say is cannot determine if reaction happens. Okay. We say cannot determine if reaction happens. We don't know. There's no physical way for us to tell if this reaction actually happens. Okay? That's because there is no change in state. So that'll be that. All right, take care, everyone.